And a link to all the previous tutorials in this series is available in the upper right hand corner. You should watch those first or you will be confused. And of course, all the code in this tutorial is available in a link underneath the video in the description. Now the first thing I'm going to create here is a stack. And like I said before, I'm going to represent this as if it is an array, only so I can show you how it will build itself interactively over in the right hand side of the screen. And this stack array is going to hold all of the values that are thrown on the stack. Now there are different things you need to monitor if you're using a stack versus a queue. Stack's a little bit simpler. We're going to have to monitor the stack size, which is going to be the size of the array, and I am going to also monitor top of stack, because remember with a stack it's last in first out, so I want to know what that's going to be, and I'm going to set that to -1, which is going to symbolize later on that it is empty. Then after we have that all set up, I'm going to construct the stack, and it's going to get past the size that it should be, and we're going to just have stack size set, which is just going to be the size of the array. Stack array, and we have to create the array. There that is. And then what I'm going to do is I'm going to fill the array with a bunch of negative numbers. And I'm going to do so that whenever I'm displaying what a stack looks like on the right side of the screen, it's going to ignore anything that has a -1 inside of it. And of course have that be stack array. And this little tool is going to require me to get a library, so I'm going to get it. And there it is. And that is all I need to do there. Now with a stack, if you want to put an item onto the stack, you are going to push it on. That is what it's called. And I'm going to push on a string onto the stack. Then what I'm going to need to do is go top of stack +1. Before I go and put something on there, I have to make sure I have enough room inside of my array, and that's what that's doing. If I do, I'm going to say that the top of the stack is 1 part bigger so that I can access this data later, and then I'm going to add whatever item was passed over into my array or my stack. Else, if I do not have enough room, I'm going to want to say that I don't have enough room, and then I'm going to display what the stack looks like on the screen like I did in the last tutorial, so you can follow along with what exactly is going on in memory. And then I'm also going to put out another message here at the end, and it's just going to be input was added to the stack so that we know exactly what's going on. And that is all that goes into pushing information onto a stack. Now if you want to get information off of a stack and remove it, that is called a pop. So if we want to pop the last item that was added to our stack, we're going to first off say if top of stack is greater than or equal to 0, and it's 0 because it's an array that starts at the 0 index. And here I'm going to do display the stack again. I'm not going to get into what display the stack does. If you want to see it, the code wise anyway, you can check that out in the code provided. And here we're going to throw a note out what precisely we popped off of our stack or removed from the stack. And again, that's just going to be there so that we know what's going on with the stack. Doesn't really have to be there. Now, just like in memory, whenever you delete an item, it's still going to be there. However, it is just not going to be available. So to simulate that, I'm going to go top of stack and make it equal to -1. Remember, I have this program set up to ignore everything that has a value of -1. And then I'm going to return top of stack and decrement top of stack at the same time. And then I'm going to go and handle the situation where the stack is empty. And I'm just going to say display the stack. I think that's where I want that to go. And then I'm going to say sorry, but the stack is empty if they're trying to get something that doesn't exist. And then I could do a return -1 or whatever. Doesn't really matter. And that is how we pop information off of a stack. Now if we want to peek, which is to see what's at the top of the stack but not remove it, pretty easy, extremely easy actually. I'm going to call display the stack again, I think, I don't know. And then I'm going to say that I peeked, and I'm going to say stack array top of stack is at the top of the stack, and then throw a new line in there. And then this guy's going to return stack array, right like that. And that is pretty much all we need to do. I'm going to show you a couple other different things, but I want to jump down into main and do some tests here so you can see exactly what a stack looks like as we're using it. So in this situation, if I want to make a new stack, I'm going to go the stack, and I'm just going to call it the stack is equal to new the stack. And I'm going to say that I want it to have 10 spaces available for me to enter information. And if I want to push information into my stack, I'm just going to do it this way. And if I execute that, you can see right here, here is the stack. There's 10 spaces. And I pushed a 10 onto the stack. See, push 10 was added to the stack. And if I want to push another item onto my stack, let's say 15, you can see 15 was added right next to it. And also we printed out another message. Now, if I want to pop the items on a stack, well, actually, let's first peek at the stack and see what's on there. And it's going to return just the 15, because remember, this is last in, first out. This is the first in, that's the second. And if I want to pop or remove an item, I don't have to tell it what item, because there is only one item it can remove. And 15 was removed from the stack. I'm actually going to say, because that didn't come out, I'm going to say display the stack afterwards. And you can see 15 was removed. Now, if I want to do some other things, this isn't that is basically a stack right there, what I just showed you. But if I want to just mess around and create a couple other different methods just so we can look at a stack, I could set this up to push a whole bunch of things at once, a whole bunch of values, and let's say that it gets a string. Multiple values is going to be its name, and I'm going to create a string array, which is going to be temp string, and then do a split to split everything wherever there's a space into the different parts of the array. And then I could cycle through all of these and go into I is equal to 0, I less than temp string, and get the length out of that. And then if I want to push them on there, I do that individually, temp string and whatever is inside of the array, because we can only work with one value at a time. Then I could jump down here again and the stack, do a push many. And let's say we do a 12, 13, 14, 15, like that. And you can see it added a whole bunch of different numbers. So first we added the 10 and the 15, and then we removed the 15, and then we added the 12 and the 13 and the 14 and the 15. So that's how we would push a whole bunch of things here at once. And then I could also, just for the heck of it, do a pop all. And we're just going to throw a for loop in there. Top of stack greater than or equal to 0. And we can decrement it, walk our way through the stack and pop as we go. And I'm just going to call pop to do that. And then bounce down inside of main and do a pop all and execute. And you can see that the stack is empty at the bottom of our screen. So there's a whole bunch of different things you can do with stacks. I also did a couple other things that are available in the code if you want to look into it further. But that is the basics, so let's take a look at queues. Okay, with a queue, like I said before, queues are going to allow you to access the first item inserted instead of the last one, which you had with a stack. And a queue is going to require a whole bunch of different things than a stack, but it's also going to have many of the same things. We're going to have an array in this situation. We're also going to monitor the size of our queue. And here is the thing that's going to be different. We're also going to monitor the front. Remember, we're going to be pulling information from the front of the queue. We're also going to be monitoring the rear or the end of the queue. And of course, we're going to be monitoring the number of items, all of which are going to be set to 0 whenever we first start out. Then, going to construct our queue classes, set queue size equal to whatever the size is that they want it to be. And as this tutorial series continues, I'm going to show you a lot of neat things you can do with stacks and queues, but I didn't want to cover too many things in this tutorial. I'm probably covering well over enough as it is. I'm going to fill the queue again with -1s so that they will not show on our screen whenever we print stuff like you see on the right hand side. And then with a queue, instead of pushing, we say what makes a little bit more sense, which is inserting. And there's other things people say, but insert works for me. Alright, so if we're going to insert something, we want to go number of items plus 1 because we're going to be adding a new one. We want to make sure that's less than or equal to whatever the value for the queue size is. And if it is, we're going to say queue array rear which is where we're going to be putting all of our new information, and we're going to be pulling from the front, and then I'm going to increment rear, the value for rear, so that we can keep increasing the size of this array. I'm also going to, of course, increment the number of items because there's more. And then I'm also going to put a little message on the screen that something happened. Obviously, you don't need that, but it definitely helps with learning what's going on. And I'll throw a new line at the end. And then I'm going to say else. Well, we've obviously had a problem. And I want to say, sorry, but the queue is full. And I'm going to show you a priority queue here in a minute, which what's really going to be different is the insert part. A priority queue is going to insert all of the information in a specific way. But of course, we're going to have to provide a way for us to remove items. But before we do that, we want to check that the number of items is greater than 0. Otherwise, there won't be anything to remove and we'll get errors. And if we get this far, we know we're about ready to remove something. So I'm going to say front, which is where we're going to be removing information from. And in a second, you're going to see where the front is and where the rear is. And it's going to be much more understandable. And like before, I'm simulating kind of like what it is like in memory. Where an item is deleted, it is just simply not accessible. It's not literally deleted, normally anyway, until it's overwritten later on of items. Decrement that. Else, well, we know we got a problem here, and that problem is going to require us to say, sorry, but the queue in this situation is empty. And then while I'm at it, I might as well also cover peek, and it's just going to say the first element is... It's amazing how quickly I can type Q and print that out on a screen. And now we can come down inside of main and start making some Qs. So let's go the Q is equal to new Q. And once again, let's say we want it to be 10 spaces in size. If we want to insert them, let's say we want to put a 10 inside of there. And let's throw a couple other different things in here. Say a 15 and a 11. Say display the Q and execute it. And you're going to see right there, insert 10 was added to, 10 was added to the queue, 15 was added to the queue, 11 was added to the queue. And you can see here where front is. That means whenever we do a remove, that's going to disappear. And you can also see where the rear is. So let's take a look at what happens whenever we do call for remove. Execute. You may be surprised by the fact that 10 is technically still here, but we can't access it because it's not there. It's no longer in our queue. And this is now the front of our queue, and this is still the rear of our queue. We could also do a peek, which is going to do exactly what you think it's going to do, which is basically just spit out the first element is 15. And we could continue to remove these items over and over and over again. Execute. And now you see the front is the same as the rear. And that is how a queue works. Now to throw a little bit more into it, let's look at what a priority queue does. I'm going to go public void, and I'm just going to call this priority insert. And what's going to be different about this is going to add items in order from high to low as they are inputted. And I'm going to have to initialize I outside of this. Then, before I put anything into it, I'm going to go number of items equal to 0. If that's going to be true, well, then I'm just going to let input do its job because there's nothing really different. So there that goes. So the regular input will be used in that situation. Else, I need to enter everything, again, like I said, from high to low. Well, to do that, I'm going to take I is equal to number of items minus 1. Greater than or equal to 0. I'm going to start at the top of the array or the top of the queue and decrement my way down through. And then I'm going to say if I need to do this because these are set up as strings. If they were set up as integers, I wouldn't have to do it. I'm going to convert my input that was sent to me to an integer and then do pretty much the same exact thing here for the value that is inside of the queue already. Queue array. Put I inside of there. So if the new input is greater than the input that is in the array that I'm testing right now, I need to copy that value further up into the array because it's going to be moved. And in that situation, I'm going to break out of this because that means I'm going to be done shifting items in my queue after I shift that one. And then I can go queue array I plus 1 is equal to whatever the input is. And then after that, of course, I'm going to need to increment rear because I got more information in there than before. And then also increment number of items because I just inserted a new one. Let's go back down into main and see what that looks like. So let's just change these into priorities. priority insert, and let's say 10, because remember it's going to sort them from highest to lowest, and we'll mess this up on purpose just to show that indeed it is putting them in proper order. And if we file save it and execute, you can see the difference between the priority queue. It's going to put everything in proper order just like that, and then delete them just like a regular queue. So